Okay, so let's just do two examples of magnetic field. This first one says the maximum household current is 15 amps. What is the magnitude of the magnetic field that produces 1 centimeter away? So if you had a wire that had 15 amps running through it, what would the magnetic field strength be about a centimeter away? So this one is pretty straightforward. The equation for the magnetic field near a wire is mu naught I over 2 pi r. So mu naught, remember that's that permeability of free space, so 4 pi times 10 to the negative 7 is that mu naught value. I is just 15 divided by 2 pi, and our radius is 1 centimeter. We do need to be in meters, that would be 0.01 meters. Our 2 pi, 4 pi, that just should cancel out to 2, right, on the top. So you should be able to calculate this. Some of you could mental math this, some of you could just use your calculator, and some of you are just not going to do the right thing. You're not going to pause the video and actually try to calculate this yourself. I would encourage you to calculate it yourself. But hopefully, after pausing the video and calculating it, you should get that it is 0.003 Teslas. Okay, and 15 amps is a pretty big current, and 1 centimeter away is not very far. So we're going to see that our Tesla values, our magnetic field values, are going to be pretty small. We're not going to have really huge Tesla values. I'd say something on the order of like 10 Teslas would be a huge magnetic field. Okay, let's try one more example. And this one was solenoids. Wow. Okay, this says a solenoid 0.3 meters long with 10 to the 3 turns per meter has a current of 5 amps running through it. So let's just identify quantities. We know that this is our length. We also know that this is 10 to the 3rd turn. So that's our N value. N is 10 to the 3rd turns per meter. And it's got a current of 5 amps. And we want to know what is the magnitude of the field inside the solenoid. So for a solenoid, remember for a solenoid B, if I know the number of turns, just mu naught N times I. So that's going to be 4 pi times 10 to the negative 7. My turn ratio, rather, is 10 to the 3, and my current is 5. So again, take the time, stop the video, get your calculator out, calculate this for yourself, and get a value. Hopefully you get 6.3 times 10 to the negative 3 Teslas. Again, pretty small value. And then the second part of the question is how does this compare to the magnetic field a distance of 1 centimeter from the wire? So if we're just figuring out, like, well, this is what is inside the solenoid, what is it just as 1 centimeter away from it? We would just go back to our B is equal to mu naught I over 2 pi r. So this would be 4 pi times 10 to the negative 7. My current is 5. 2 pi times a distance of 0.01. And we should notice that it is significantly smaller. Okay, so calculate that out. Pause the video, do the right thing. You should get that it is 1 times 10 to the negative 4 Teslas. Okay. So again, there is a magnetic field like on the outside of the solenoid, but it's really relatively weak compared to the inside of the solenoid.